So someone also asked for 9F question 7, and 9F question 7 is the one that said you've got a drinks can with a capacity of 330 millilitres. Can we think of some possible dimensions? You can look at a real can. Again, what shape is a can? A can is a cylinder, and we're looking at capacity, so we're looking at volume. And volume of a cylinder is pi r squared h. We're looking for possible dimensions of r and h. But we have a choice of both of them. You can look at a real can. Right then, we've got a real can. This happens to be one. 330 is a standard volume. How tall is that roughly? That's roughly 12 centimeters tall. So, if they want us to do that, let's start with that as a possibility, shall we? If the height is 12 centimeters, can we find a possible radius? 330 milliliters, 12 centimeters. Perhaps that was the sticking point for some of you. 1,000 milliliters in 1 litre, milli a thousandth. 1 litre is also 1,000 centimeters cubed, and you really should know that from your science. So 1,000, 1,000, that means that we've got 1 milliliter is the same as 1 centimeter cubed. They're the same thing. So what do we start with? We've got this formula for the volume. If the volume is 330 and we know the height is 12, we've got pi r squared times 12. Can we rearrange that? Yes, we can. We can say that r squared is 330 divided by 12 pi. We could say that r is the square root of 330 divided by 12 pi. And from that starting point, we can get an answer. So let's turn that on. We've got the square root of 330 divided by 12 pi, which gives us 2.958, 2.96. That's centimeters, that's millimeters. Do we really want to be talking about tenths of millimeters? I think 3.0 centimeters is fine here. Well, that's all well and good. Are you going to take a drinks can into the exam? No, you're not. So it's a question where you've got a cylinder and we know the volume. They're asking you to think of any pairs for those. Okay, that was a height of 12. Let's say randomly in the exam you thought 5 centimeters was a good height for a drinks can. So we've got 330 is pi r squared times 5. R squared is 330 over 5 pi. So we're dividing by the 5, dividing by the pi. R is the square root of 330 over 5 pi. Oh look, it's virtually the same as that, isn't it? I've just changed the 12 for a pi. So in fact, let's just edit that. Let's change the 12 to a 5 there and get 4.58, 4.6 centimeters. As I made that smaller, I've made that wider. 12 has become 5, 3 has become 4.6. There might be some of you saying, well, that's all well and good. I've chosen the height twice. What happens if I said, okay then, I've got a cylinder, and for whatever reason, I think that, I don't know, 2 centimeters is a good radius for a drinks can. What would the height be? It all keeps coming back to the right formula, doesn't it? V equals pi r squared h. V equals pi r squared h. Good practice on the exam. Right, the formula you're going to use substitute in the values you know, and then either you could work pi times 4 out, or even better practice is rearrange everything. 2 squared is 4 pi. So what we get there, that had the square root, I'm going to start from scratch, so I'm going to start with 330 over 4 shift pi 26. So making this a little bit narrower makes it far taller. Okay, so this question really was about, what was this question actually about? This question was knowing how milliliters relate to centimeters cubed, and then just being prepared to make a start somewhere. Whether you started with 12 or started with 5 or started with a radius of 2, quoting the right rule, substituting values in, and then rearranging. And that's how to do question 7.